Have you ever just looked at a traditional robot and thought, man, that thing is incredibly clunky, right? I mean, they're heavy, they're super rigid, and they completely rely on these fragile electric motors. But what if we could actually build a machine that moves completely on its own, like with absolutely zero motors?
Welcome to Integratekh. I'm so thrilled to have you here for today's explainer. This is the channel where we take the absolute most mind-bending new findings from the tech world and, well, we just break them down into simple, engaging stories. So today, we're diving into a massive breakthrough where literally no motor is needed. We are talking about a world where the materials themselves actually are the machines.
Okay, let's just dive right into the challenge here. For decades, traditional robotics has been trapped by this one major limitation. Just picture a typical robotic space arm. It relies on heavy, rigid links and really complex electric motors, right? And if just one motor breaks, the whole arm is basically dead weight. But then you look at nature, an elephant's trunk or an octopus tentacle. They achieve this incredibly fluid, robust movement seamlessly, without a single bone or metal hinge. So the big question is, how on earth do we copy that?
To solve this massive limitation, researchers are turning to a seriously groundbreaking method called 4D printing. Now, you probably already know all about 3D printing, building an object layer by layer, right? Well, 4D printing adds that fourth dimension, time. We're talking about 3D printed objects that are actually engineered to actively change their shape over time, reacting entirely on their own to changes in their environment. It's wild.
So instead of trying to build some tiny, complex electric motor, the researchers decided to use a plastic-like smart material. It's called a shape memory polymer. I know, that sounds like a bunch of heavy jargon, but honestly, just think of it as a piece of plastic that actually has a physical memory. When it reacts to a simple change in temperature, it automatically remembers and returns to a very specific shape.
And this perfectly illustrates the absolute secret sauce behind this whole operation. The researchers didn't just use one material for this, they used two. By combining an active material, which is one that really wants to move at a lower heat, with a passive material, we can control exactly how and where the object bends. That passive material acts kind of like a rigid anchor. So when the active material pulls, the passive one forces it to bend exactly where we want it to.
To figure this out, the researchers used a super smart computer algorithm to arrange these active and passive materials into really specific, tiny building blocks. And depending on exactly how those two materials are layered inside the block, adding heat changes everything. The block will specifically bend, totally twist around, or just stay perfectly rigid.
But, this brings up a pretty massive question. How do you actually program a simple block of plastic to physically move on its own, especially without using a single computer chip or a single line of digital code inside it?
Well, they use what's called a thermomechanical programming cycle. Now, don't let those big words scare you off. Think of it like this. Imagine you take a completely dry kitchen sponge. You get it wet. You stretch it all the way out, and then you freeze it solid in your freezer so it's locked in that stretched out shape. Then, later on, you drop it into warm water and just watch it magically shrink back down to its normal size.
So, the crucial takeaway here is all about that temperature cycle. By heating the plastic past its transition point, physically stretching it out, and then cooling it back down, they physically lock that movement into place. The energy is literally stored right there inside the material, just waiting for the exact right temperature to trigger it to move again.
And what's really fascinating is seeing the real-world proof of this. These aren't just computer simulations we're talking about. These are actual 3D printed polymers. You can literally see them curling up to 25 degrees when they're triggered purely by ambient heat. So the concept is totally proven, which meant it was time for the ultimate test.
Let's move on to the results, because this builds up to a pretty amazing grand reveal. The researchers actually challenged their computer algorithm to take these simple, bending and twisting plastic blocks, string them together into one long, continuous chain, and have them tie a complex knot completely autonomously.
And here is exactly what happened. The algorithm calculated the exact sequence of blocks that would be needed. They printed this totally straight, rigid chain of the blocks. Then, when they activated it simply by applying heat, that straight printed chain curled and twisted itself perfectly into a complex 3D knot, exactly following its target path. It's like watching a magic trick, honestly.
I just really want to let that sink in for a second. Think about that result. There is not a single electric motor.
There is not a single wire, and there is absolutely no central computer processor inside that knot driving the movement. It is entirely driven by the physical properties of the material itself.
Now you might be sitting there wondering, okay, this is a very cool laboratory trick, but why does a self-tying piece of plastic actually matter outside of the lab? Like, how does this affect people or industries, or just the future of technology in general?
Well, because the material is the machine, the possibilities are honestly endless. This research paves the way for tiny medical devices that you could safely swallow, which then automatically unfold inside your body without needing toxic batteries. It means we could create incredibly cheap, lightweight, motorless prosthetics for people who need them, or even highly robust gear for deep space exploration that won't randomly break down in the freezing cold. We are truly entering an era where the material is the machine. If our plastics can move, bend, and work completely on their own, what happens to the factories of tomorrow? Seriously, let that sink in. If you loved diving into this explainer today, be sure to hit that subscribe button, give it a like, and drop your thoughts in the comments below. And stay tuned to the Integratekh community for more simple, clear tech findings. So, what tech mystery should we explore next? Let me know, and I'll see you in the next one.